It's Josh here from Kelford Cams, and today we are going to be doing some cam timing on this RB25 Neo engine, making sure that our opening and closing events in regards to piston position is very, very important. So anyone with an RB25 hydraulic engine or solid lifter Neo, they do come factory with adjustment on the VCT cam gear. In this case, there has been an aftermarket, Franklin Performance I believe, option fitted. This allows you to adjust the front of the cam gear without actually removing the cam gear. Right, first up is our degree wheel. The degree wheel is going to be measuring the amount of degrees of crank rotation. Alright, so next up is putting a dial indicator into number 1 spark plug hole. This here is going to be for us to measure true TDC. And we are going to zero our pointer on the degree wheel. The reason we're doing this is because there is always a piston dwell that's dependent on rod ratio to the length of the conrod in regards to the stroke of the crank. Because there's going to be a point that the piston stops but the crank still moves, we actually need to find the middle ground of that. So by doing this procedure allows us to find true TDC. First things first, we're going to come up to 50 thou before top dead center. We're going to stop at that point and see what number we have on our degree wheel. Cool. So we are looking at 12 degrees before top dead center on our degree wheel. Alright, so we've found our position, 50 thou before top dead center, and we're going to come up to TDC. And then 50 thou down the bore. And we are on 14 degrees after top dead center. We've done our 50 thou before TDC, 50 thou after. We've got our 2 numbers on the degree wheel, and what we've found is we are actually a degree out. What we're trying to do is actually split the difference here and understand how much dwell is in this engine. By moving our pointer to 13 degrees after top dead center, just like that, will allow us to be true TDC. All right, so we've made our adjustment to our pointer position, and now all we're going to do is just check our work. So we're going to basically go through the same procedure again. We're going to find 50 thou before top dead center, just like that, and we're going to check our pointer position, and we are bang on 13 degrees before top dead center. So the last thing to do is just confirm we have the same number on the other side. So we're going to come up to TDC, back down to 50 thou, and we're going to see what number we have. And just like that, 13 degrees. So now we're happy to move into the next procedure, which is setting up the dial gauge onto the intake cam and degreeing the intake camshaft. Okay, so next up is we're going to set up our dial indicator onto our intake bucket. This can be a painful task, unfortunately. There's not a lot of room between the camshaft and the bucket. So once we've set it up, we want to do some testing to make sure that there's no fouling when we rotate the camshaft. An important note is to make sure our pointer is straight up and down. Sometimes if it's on an angle as such, we can have a discrepancy with our lift. So just make sure that we're square. So now we're set up with our dial gauge on the intake cam bucket. We're going to go through the motions, look at the opening and closing numbers, do some maths. All right, here we go. So the intake valve's about to start opening. We're going to come up to 1 millimeter of lift. We're using an imperial dial gauge, so 40 thousandths of lift. Perfect, and we're gonna see what number we've got. 9 degrees after top dead center. Because this is an RB25 Neo engine, it runs a VCT intake cam gear, so that's variable and it allows it to basically start life in a retarded position and advance based on ECU control. Now we're going to go all the way up through to peak lift, and come back down to 1 millimetre or 40 thousandths before the valve closes. So I'm going to count my way up. So that's 100 thou, 200, 300, 410, 400, 300, 200, 100. And 40 thou or 1 millimetre before closing. And we have 57 degrees after bottom dead centre. Our maths are going to tell us the size of the camshaft and duration, and also the centerline that we're in position in the engine. Our opening number is 9 degrees after top dead centre. Because we're opening after TDC, we actually need to take that number away from our equation, and I'll explain. So we are opening at 9 degrees after top dead centre, TDC being our 0 point. A part of our equation is adding 180 degrees. That 180 degrees is TDC to bottom dead centre. So we're going to start with 180 degrees. We're going to remove our 9 degrees and we're going to plus our 57 degrees to give us a duration of 228 degrees at 1 millimetre. From there, we're going to divide our 228 degrees by 2 and we're going to add our 9 degrees to give us an intake centerline of 123 degrees. So we've established our intake camshaft in the static position. Static meaning the VCT cam gear is not advanced from its home position, is on 123 degree centerline. That centerline is perfect for this application. What happens is the factory VCT cam gear on an RB25 will advance 20 degrees, so that will put us on 103 intake centerline when activated via the ECU. So, first step is you want to set up the dial indicator onto the exhaust bucket. Like the intake side, this can be a little bit fiddly. Right, so we have our dial indicator set up on our exhaust camshaft. Going to go through the motions to degree in this cam, check our opening and closing figures, and do some maths also. Check out this awesome Kelford cam gear. This is the KCG 25 for the RB25 and 26. Now, these are machined after anodizing. They look so good. Here we go. Alright, so like the intake camshaft, we're going to come down to 1 mil of exhaust valve movement. Perfect. So the exhaust valve opens before bottom dead centre. Bottom dead centre here displayed as 180 on our degree wheel. So we're going to count the numbers up. 10, 20, 30, 40, 50, 55, 56, 57, 57 and a half. We've got our opening number of 57 and a half. Now we're going to go through the motion all the way up to peak lift and back down to 1 millimetre before closing. The number is 1.5 degrees before top dead centre. So we have our opening and closing numbers. The exhaust valve opens at 57.5 degrees before bottom dead centre and closes 1.5 degrees before top dead centre. So we'll do the numbers. 57.5 plus 180 equals 237.5 degrees. Because we are closing before top dead centre and I've added 180, we want to remove this 1.5 degrees from the equation. 237.5 minus 1.5 equals a duration of 236 degrees at 1 millimetre. And 236 divided by 2 equals 118. Plus 1.5 equals 119.5 degrees. These cams are actually in the right spot already and not worth us moving them. So we're going to leave them put. This engine is looking really, really good. Degreeing your cams is a must. It allows us to make sure that there isn't something wrong and our camshafts are in the right position. In this case, we haven't actually had to move them. So that just shows us that obviously our engineers at Kelford Cams and the machinery that we use is very, very consistent.